Introduction to Programming Languages. In this video lesson, we shall discuss about machine language, assembly language, and the high-level languages. But first of all, let us understand why a programming language is required. A programming language helps us in writing instructions or the commands so that the commands are executed by the computer machine. We know that computer does not do any job on its own. It needs to be instructed in the form of commands, and the programming language helps us in writing those commands to the computer. Today's computers are incredibly fast and getting faster all the time. Yet with this speed comes some significant constraints or limitations. Computers only natively understand a very limited set of instructions and must be told exactly what to do. The set of instructions that tells a computer what to do is known as software or the computer program. And we are learning about the programming languages because we want to write those instructions or the set of instructions which would direct the computer to do some particular task. The computer machinery that executes the instructions is the hardware. A computer CPU is incapable of speaking C++. The very limited set of instructions that a CPU natively understands is called machine code or machine language or simply an instruction set. So then why we are talking about C++? Because CPU does not understand the C++ language. Then why we are talking about C++? Actually, there are certain limitations or drawbacks associated with the machine language. We shall discuss them here in this video lesson. It is interesting to note two things. Each instruction is composed of a number of binary digits, each of which can only be a 0 or a 1. Means every instruction is composed of, or we can say every instruction is a combination of zeros and ones. These binary numbers are often called bits. For example, the MIPS architecture instruction set always has instructions that are 32 bits long. Other architectures such as the x86, which most probably you are using, have instructions that can be of a variable length. It may be of 16 bits, it may be of 32 bits, it may be of 64 bits, etc. Now, for example, here is a x86 machine language instruction. This is an instruction, and here we see that it is the combination of zeros and ones. This instruction has been composed of a number of binary digits, that is zeros and ones. Now, to write an instruction in such a format, it's quite difficult because we are not used to such type of coding, whereas the CPU understands only this code. Each set of binary digits is translated by the central processing unit into an instruction that tells it to do a very specific job, such as adding two numbers or comparing two numbers, etc. So different types of CPUs will typically have different instruction sets. So instructions that would run on a Pentium 4 would not run on a Mac PC. It means the instructions are CPU dependent. Back when computers were first invented, programmers had to write programs directly in machine language, which was a very difficult and time-consuming thing to do. Initially, it was possible only to write codes in machine language only, and which was a very tedious job. Because machine language is so hard to program with, means as in the previous example we have observed that it is very difficult to write machine language instructions, because machine language instruction is the composition of, it is composed of binary digits, and we are not familiar with that pattern. So the concept of assembly language was invented. In an assembly language, each instruction is identified. Each instruction is identified by a short name rather than a set of bits. And variables can be identified by names rather than numbers. This makes them much easier to read and write. However, the CPU cannot understand assembly language directly. CPU understands only the machine language. So, the codes which are written in assembly language, they must be converted into equivalent machine language. And the special piece of software which converts the assembly language codes into machine language is known as assembler. It means we require an assembler. If we are writing a program in assembly language, then we require an assembler to convert our assembly language codes into machine language. Assembly languages tend to be very fast, and assembly language is still used today when speed is critical. However, the reason assembly language is so fast is because assembly language is tailored to a particular CPU. Assembly programs written for one CPU will not run on another CPU. Furthermore, assembly languages still require a lot of instructions to do even simple tasks and are not very human readable. So we have written this example here. This is the machine language instruction, and its equivalent assembly language instruction is written here. So to execute this instruction means this instruction may be executed by the CPU directly because it is written in machine language. Now if this instruction, that is move al, 061h, if it needs to be executed, then first of all this instruction has to be converted into machine language, because this is in assembly language format. So we need a special piece of software, assembler, that will convert this assembly language instruction into equivalent machine language instruction, and then it may be executed by the CPU. To address these concerns, that is the problems associated with the machine language as well as the assembly languages, high-level programming languages were developed. C, C++, Pascal, etc. are all high-level languages. Programs written in high-level languages must be translated into a form that the CPU can understand before they can be executed by the CPU. It means we need some special piece of software which would convert our high-level language codes into machine language, and that job will be done by the compilers and the interpreter. So a compiler is a program that reads code and produces a stand-alone executable that the CPU can understand directly. Once your code has been turned into an executable, you do not need the compiler to run the program. The job of the compiler is over once your source codes or your high-level language codes are converted into executable form, machine language format. So here we have high-level language codes, or sometimes we call them the source program or source codes, means source codes written in some high-level language such as C++, and those codes are directed to the compiler. Now the compiler shall check the codes, these codes, for some syntax errors, etc. And once your program is free of syntax error, then the compiler would convert them into executables or machine codes. Okay, once the executable codes are generated, then the job of the compiler is over. Then these executable codes are directed to the CPU, central processing unit, to get the desired results. CPU would execute the instructions one by one and would produce one by one, or would it would execute your instructions and would produce the program results, that is the output. High-level languages have several desirable properties. High-level languages are much easier to read and write. Here is a sample instruction that we have written in C++ language, and we have written a equals to 97. It seems just like a mathematical equation, and it could be understood by everyone who knows a bit of maths and all. They require less instruction to perform the same task as lower level languages. In C++ you can do something like a equals to b into 2 plus 5 in one line. Means we are multiplying b with 2 and adding 5 to the result and assigning the result to the variable a. If we had to write the same program, if same set of tasks was to be accomplished by using the assembly language or the machine language, we had to write 5 or 6 different instructions for the same. So it is possible to write this instruction in one line if we are using C++ or any other high-level language. You don't have to concern about yourself with details such as loading variables into CPU registers. The compiler or interpreter takes care of all those details for you. But if you're writing some assembly language codes, then you have to mention the reference of the register to which you want to copy the data, etc. So if you're using high-level language, then all this type of job is done by compiler for us. In the next video lesson, we shall discuss about the introduction to the program development or the software development. What are the different steps involved in developing a computer program?